I guess my intent with you guys in talking about this again was just to point out a couple things that I am seeing in this waveform. This is the picture of our old distributor, right, with the spout connected. So to zoom out a little bit more, let's just kind of get a baseline here. We can see that our crappy one is right here. You see the blue trace? Yep. And then the same one, I believe, is right here after the fat one. If we count these, there's 1, 2, 3, 4, 5, 6, 7, and then 8. I actually should have counted that one as 1, I guess. Just want to see if we got a repeat pattern here. Count this as 1, 2, 3, 4, 5, 6, 7, 8, back to 1. So you see the same like fat area here. Remember we were talking about this yesterday. Something else looking at in this capture, you see the other skinny one there too? Yeah. So I believe when we drove this vehicle that it was multiple cylinders. It wasn't just a single cylinder miss. And we were seeing that across some of the secondary ignition waveforms where they were dropping out in other cylinders too. But I wanted to point out, I guess, what I know about this. We have the new distributor. We're going to throw that in today. And then we'll retake these captures. This is with the computer involved in the timing. Okay? With the computer not involved, let me show you that. With the computer not involved in timing, this might be actually easier to see this. If I do 3 windows, I like with the Pico that I can separate them easier. This one I can still play around with. What, Kendall?
I thought that was the Pico.
No, this is the Varus. I grabbed the file from the Varus and loaded it onto my laptop. Because I have that program called ShopStream Connect, the one I told you guys about. That's what I'm using right now. So it allows me to manipulate the file, and it's not just a JPEG image. It's the file itself. Maybe not this particular layout. The blue trace is what I want you guys to focus on for a second. Our blue trace is our coil firing events. Okay? And what you'll notice is the PIP wire, which is the yellow wire, the yellow trace. The rising edge of the PIP is the falling edge of the coil. Can you see it? So every single time that this PIP signal is increasing is the same time that we're taking this coil current ramp pattern, our ignition coil primary circuit, and we're turning it off. So this is a system that is timed exactly with the PIP signal. Our base time signal is that PIP signal or our crank sensor signal. Can you guys see that? Every single time that PIP is rising is when this coil is being turned off. So what you could say is the computer's not controlling this at all. The spout signal is the green trace. You see where it's timed at, but the module's not using that signal right now. Okay? So look what it looks like with the computer now involved. It takes the timing. Notice the trailing edge or the fall. Let's look at this one over here. The fall of the coil ramp is no longer timed with the rise of the PIP signal. What's it timed with now? It's timed with the rise in the spout signal. This is my spout signal. This is my PIP signal. So you see now the computer's taken over with when to shut that coil off. When does spark timing occur? Spark timing occurs when we shut the coil off. When we shut the coil off is when we have a spike and that's when spark occurs. So can you see that this is more advanced? This is more advanced timing when we're going after, when we're using the spout signal compared to the PIP. Make sense? So this is just, I'm just pointing out things that I know are occurring. As far as the rest of it, I think that's about all I got. You know, like what we were debating yesterday, and in these cutoffs, is there anything else that we could add to that? I'm just not sure. I do see that the PIP signal falling edge is the same time we're getting that cutout in the spout. I can see that relationship, and I see the same thing. This one's different though. Look at the falling edge of this. There's a falling edge here. I see the spout dropping. I really don't know.
The second one is more.
The second one, it drops again to the green.
Yeah, there's 2 drops.
In the green one.
Yeah, it drops a little bit.
Are you guys looking here?
No, the second one.
So there's 2 in that one. I'm not really sure why.
There's 2 in that one.
Yeah, the second wave.
At the bottom.
Yeah,
At the bottom of the...
Green.
Oh, down here. You guys are looking here. And then here. Are you comparing like these 2?
You're saying that there's 2 because like there's also a drop there too.
Oh, yeah.
Is that something the computer would decide?
Honestly, what the way the PIP and the spout are wired internally on that module, I don't know.
It's so fun.
I promise you that this pickup's going to fix this. But can you see why I would have put a computer in this the first time I saw it? It looks like, you know, for the system to run normally when you unplug the spout, which we know it does because it goes into this basic mode, and then to run horribly when you plug the spout back in is telling you have a computer problem. I've done enough of these. I am 100% confident that this pickup's going to fix this. I just wish that I could tell you why up here. I'm pretty good at doing this type of thing, and I can't do it in this scenario. And I was hoping that maybe if I pulled it up on the screen and could talk to you guys and we could talk about it for a minute, maybe we could pick out some other things. I'm not ready to quit yet, but I think I'm done.
So you said some new distributors can cause this?
New distributors? Yes. This distributor that is in this vehicle is not very old. It's been done within the past year, so it's not an old distributor. I have seen these bad right out of the box. Granted, it might be a reman distributor, but I've been to garages. The one I'm talking about where I got my butt kicked, it was a newer distributor that was just replaced and had this issue. Let me move over a little bit. Look at a couple more of these. See if there's anything else you can see. I do see consistently in this that the blue trace, again, the coil ramp turn off where spark occurs, is being initiated by the turn on of the spout. We can see that shift. That's the only real clear thing we saw between the spout being plugged in and the spout being unplugged. The rest of it and why it's clipping these signals, we can see that when this is being clipped on the PIP signal, you see the spout is also having that same thing occurring. So we see the clip in the PIP and we see that area in the spout. And I believe when you read about this, it actually talks about these spout and PIP signal relationships, but I don't know that it would necessarily help us. I'll maybe try to dig some of that old information up.
Is this all that I don't?
These pictures were taken, Kendall, when we raised the RPM a little bit, because that's when our misfire was most pronounced, and that's when we see my fat pulse there coming up, and see my little tiny pulse right there.
Maybe there's like a chipped tooth on that thing. That's why.
It's not a chipped tooth. Definitely not a chipped tooth. There's nothing visually on here. There's also some stuff that old material would tell you to push on the the stator, what they called the stator, which is the top of the inside of the pickup signal, and to push on it, and if it was like real soft, then that was an indication of failure. And I never saw an internal one that was soft, so I don't know what they were talking about with that. Nothing visually that you would see here, Randy, at all. It's not a tooth. Remember that these clips and these signals are not occurring from a mechanical piece. This is being done electronically, these change-ups in these signals. And it is normal to see these types of clips occurring in the PIP signal wire like we're seeing. But what's not normal is when they start to become not uniform. So let's see if I can show that one more time. We want these to be uniform and even. And when we start seeing issues, can you see that this one here, and this one, and this one? See how they're changing? They shouldn't look like that. It should be even, consistent, all of them. See if I can show you that a little bit more clearly. Let's move over a little bit further. Yeah, and you see the see these ones? Not bad, right? Pretty even. This one is a sync notch that's in the distributor gear. So I'll get a picture of the distributor gear and throw it in here for when the video is done. And what you're looking at is a bunch of teeth that are all even and uniform. There are 8 of them. As the distributor rotates, there's 8 teeth, but there's one tooth that's thinner than the rest for number 1 cylinder piston position, for injection timing, not for ignition timing. So it's normal to see, and the one I'm talking about is this one right here. It's normal to see that guy being a little thinner in the PIP signal than the rest of them. Okay? But what I'm looking at again, these guys here, and you see that one? How much that has changed? And that's your indicator, man. You start seeing that. Let's move that. Whoops. So we are focused. Watch this one right here. And I'm going to move this over. Which way moves it a little bit? Darn it. I just want to move it a little bit. Why is that not letting me? I guess zoomed out on that level. Back in. There we go. I want our bad one. Where's it at? Yeah, it's after this one. Good, right? This is our sync for the number 1, and then look how fat. Cause and effect. I can see the effect. Cause I can't answer still. Don't know that I'd be able to. I'm sure an engineer would come in when I post this video and offer some great information. So if you guys are watching this later, pay attention to the description. There's going to be some real good conversations, I think, on this one. And maybe that'll be the point where we learn how the PIP and SPOUT signals are being affected and are clipped and are controlled, and why the faulty PIP signal causes this. What's faulty in the PIP circuit that causes this? I don't know.
It seems to always be after that one.
It does, doesn't it? After.
Look at the spark line off of it too.
You talking about this blue trace right here? This you're talking about that.
Yeah.
Now think about that. That's when spark occurs on all of these. So it's the tail end of the coil current ramp. The blue trace is where spark occurs. And I don't know that necessarily tells us anything, because we would have one of those in every single one of these. We just happen to pick it up in this particular one. But I think what Kendall said was what? Which one were you looking at?
It's always after the one that syncs the injection time.
This is the one that syncs the injection timing, I believe.
The long one's always after that.
The long one is always after that. Good. Yep, and so you're looking at that right there. After this guy, right? After this guy, then the next one has this long cutout in the PIP, which gives me a really long, coil dwell time. And then the immediate result of that after is a really short one, and that's the one. This is the one that's really causing our number 2 misfire. What's our firing order on this truck?
1-5. You want to go get it off?
Can you grab it real quick?
What if you go forward more? Is there another one after that?
I'll move it in 1 second. I want to look at this pattern here real quick. I think it's our number 2 that's... I'm pretty sure this is number 2 right here. We're going to find out here in a second. And it's going to matter if this one is truly the number 1 cylinder with the sink.
It's 15426-378.
1542.
Yep. 6378.
1542 6378.
Yep.
So which one's this? If this skinny one, here's a different version of what we're looking at on that distributor. 4. On this distributor, and then it repeats itself again. Does that make sense what I'm talking about with this guy here and this guy here? Every distributor rotation we have this smaller notch, physically a smaller window that identifies number 1 cylinder. So our firing order then, if this is the case, it should be this one. This is number 1. Okay? Let's see if we did this right.
Yeah.
This is number 5.
4.
This is number 4.
2.
And this is number 2. And that's right where just naming the PIP signals. Now, our timing's a little advanced from the PIP right now because we're using the spout for the timing. Kind of makes a little bit more sense over yesterday's stuff. Right? This would be, when we were controlling this in module mode, it was the rising or falling of the PIP that turned the coil off. The rise of the PIP was the fall. Okay, so you understand that this, if we were in base mode, that this one rising down here would be turning which coil off? The one to the left of it or the one to the right? Yes, it would be turning this coil off. So it would be the fall of this coil would be being controlled by the rise of this PIP if we were in module mode. And so just to the left of it is the cylinder that is being fired. And it is the number 2. My point is this. It is the number 2 in our scope pattern that matches the number 2 dropouts that we saw physically from the spark tester.
Yeah.
That's pretty cool. I'm really glad to see that this is the number 2. That was the one we were focused on the whole time based on our secondary ignition waveforms. That was the one why I made you guys switch the plug wires, switch the plugs, no change, a physical dropout in just the number 2 cylinder. You would swear on every single system out there that it was a cap and rotor problem. This is not a cap and rotor problem. It's cool we got a new distributor. The owner did give us a cap and rotor for this.
Yep.
But when we put this back together and do our after pictures, we're not putting the cap and rotor on until we're done. Because I want to prove it. So 1542, that's pretty cool. And I agree with what you said, Kendall, that it seems like when we see the number 1 cylinder seems to be initiating this whole sequence of events. Because once we see the number 1 skinny pulse, it's the next one over that really gets messed up by it. So we see this guy, and then we see that really long clipped area afterward. And then it starts to get better after that, doesn't it? Like the rest of these seem more consistent. Let's see if we see that same pattern. Let's go through a couple more of these. Kind of tough to move this over. There's one that's messed up in more than just the number 2. What cylinder is that's number 5, huh? Is 1 and then 5. Here's my number 1 again. Number 5 was screwed up on that one. We were seeing this in other cylinders. I think number 5 was one of them.
Yeah, it was 5 and I think 7 and 8.
5, 7, and 8. But again, these really long clips that are in there, this is more what we want to see. There's my number 1 again coming up on it. I wish I could move this differently than I can. Like it's difficult to see the next picture over.
It's skipping a whole thing.
Yeah, what I want to see is I want to focus on this one and then move it over a little bit, and it won't let me. I think the single one should. Where did it? Did it move? Did it just move that to there? Is that where it went to?
Yeah.
Let's try it again. Let's go one more click. See if that. Yes, it did. So now we're here. You follow?
Yep.
Cool.
Right after that.
So now we're here. So there's my number 1 again. What do we see? This big fat pulse. And then this.
Battery normal.
It's the same. Is it the same pattern?
It's the last one.
We get my number 1 and then 5. Yeah, 5. Wish my memory was better. 4, 2. We are seeing a pattern. We're seeing a repetition. We know the spout's controlling the timing in the module mode, and we know the PIP controls the timing in when the spout connector's unplugged, and that's about as far as we can get. Kendall, go ahead.
I see the one again. It is definitely the pattern.
Should we see if we can see it zoomed out one more level? Then we'll go to the car. We'll put this distributor in and take a look at it. This is where's my number 1 in this? Let's move it over just a little bit here.
It's really easy.
Oh yeah, it's very.
I want to get my number 1 further down on the screen here. I think this is my number 1 right here. Then 5, then 4, then 2. Yes? Let's do this a couple times here. Naming the yellow trace. 1542. This is 6, 3, 7, 8. Back to 1. Definitely a repeating pattern. After the cylinder number 1, look at the length of the clip in the PIP signal. See it? That big clip in that is what you look for, guys. You want to troubleshoot one of these in the future, when you see these big uneven clips occurring in the PIP signal, you need to replace the crank sensor, the distributor. Best I can do. Coil dwell.
Strong power.
What's that?
So it's also strong power, like right after the first cylinder, and then it drains off.
Yeah, exactly. And by strong power, I mean you can see the dwell time would be exactly that. We're holding this coil charged for, I think, too long of a period of time, and it's affecting the one right after it for whatever reason. It's doing that. Something else to point out. Do you guys remember when we started troubleshooting this? One of the first tests that I had you guys do was I had you guys check the, hang on, I'll pull it up. I think I have it. I had you guys find, some of these were the Vantage Pro. No. I had you guys check the coil signals, and if I turn this other stuff off, just look at the blue trace for me for a minute. And what I had you guys do, remember when it was misfiring and I said, can you look at the coil firing events for me? Because I wanted to know what it looked like. What do you think was on my mind whenever I told you guys to do that? This system, this distributor, I've been here before, got my ass kicked by this thing before. You understand now why I had you do the coil events. What was I looking for? I was looking for a weird gap in the coil firing events. But what did we forget when I had you guys do that test? Maybe not what did we forget. What did we not know at the time when I had you guys do that test?
Something wasn't plugged in.
That spout connector was missing. And when you have this problem with the spout connector unplugged, how are your coil firing events? Good. We just have no spark advance. That's what we're looking at. This is good signal, spout unplugged. That's why we missed it. Let's look at this in the same view now. Kind of have the really kind of pops there as far as what I wanted to see. When you guys originally did this, that blue trace at the bottom, this is what I was looking for. And Randy, you're right about that spike being there pretty consistently with that bad one. Yeah. But then again, we're also seeing it here and here, so that kind of changes it a little bit. I'm not so much, I don't know that the spike shows us really anything more, but do you see what you don't want to see on any distributor engine? Right? Where you got one coil that's firing over and over and over again for every cylinder, you should not see that kind of dwell time variation. And what happens when your dwell time is very small, like this? The coil doesn't charge like it should be. The magnetic field is weak, and when it does collapse, what kind of spark do we have?
Very smart.
Weak spark. I don't know if the camera showed that. I hope it does. I hope the refresh rate of the camera, the frequency of the camera, is timed enough to show how weak that spark was at times. There were other times it fired and it was actually pretty strong, right? We saw a pretty strong hit on that spark. And then other times it was weak, and then other times it was not there at all. And we have a few pictures in here that you can see an area that we wouldn't have spark.
Oh, wow, yeah.
What do you think that one's going to do?
Yeah.
Probably not spark at all.
Oh,
Same with these guys, right? Probably not spark at all.
Those downward spikes.
Yeah. The downward spikes.
I don't know.
Remember, the downward spikes are when the ignition is firing. And that's really where we're generating 40, 50,000 volts in this coil every single time. And so that would be an area where I would expect to see a spike. Those spikes that are there don't bother me at all. Cool? Okay, so let's put the distributor in. and then we'll redo our scope captures to see what it looks like, and then we'll wrap it up. We'll go from there. I don't know there's anything else I could explain to you as far as the why part. What is physically bad inside the crank sensor that's making it do this? That part I cannot answer. And I tried doing it before, and I tried again just now with you guys, and I don't have an answer for you. Wish I did. I don't. This really shows it. You see what I don't want to see? Let's pick one in the middle. Compare the two. When we're done, we're not going to see that. They're going to be even, uniform all the way across the board. All right, let's go do it. This is our first after shots. Unfortunately, we had to also replace the cap and rotor because it came with the distributor, and the old cap did not fit properly on this distributor. But I promise you guys, it was not a cap rotor issue. We know that by looking at the primary. Let's take a look at our secondary ignition first. It just even sounds smoother. All right, so to get the same thing, just raise the RPM a little bit. Beautiful. Give me a quick snap. That sound. That's quicker than that. Raise it just a little bit. Alright, great. No misfire at all. Next thing I'll show you is the PIP and SPOUT and coil current signals. Again, you hear how nice and smooth this is running. I'll let you see what the scope looks like. About right there was where our miss was before. Yep. Alright, good. We'll pause that picture and we'll zoom out on it. I think we'll be better off talking about this in the classroom than right here. I'll just let you get a quick view of it. I think the one that really helped us see this in the classroom was when I did 3 separate windows. See how consistent and uniform our patterns are? See how nice these look? See your sync pulse for your number 1 and then all your cutouts. This is with the spout connector connected, right? Absolutely a fix. We'll save this picture and we'll review the before and after again in the room. Spout disconnected. Go ahead and raise the RPM a little bit. Okay. And then we'll save this one, and I think we'll go into class and load these pictures up and talk about it. We finished the Bronco. New distributor was the fix. I have a few other people that were not in here on the last segment, so you guys may have some other questions. I'm not sure I'll be able to cover all of it without it being a repeat of everything. I'm not doing that. I'll show you a basic overview, you guys that weren't here, on what you missed for the rest of us that were here through this project. This should be pretty straightforward. And for those listening, the other group that wasn't here was not slacking, so I don't want to hear any crappy comments. They were doing other projects, other cars, so no problem, right? Cool. All right. This first one is the spout unplugged with the new distributor. That is not the first one I want to look at. I want new distributor with the spout connector plugged in. Let's take a look at this waveform. And again, we can see some characteristics that we know, which is the spout signal, the green trace. A rise in the spout is causing a fall in the coil current ramp pattern, the primary pattern. So we see that same thing we were seeing before. Something else I didn't mention to you guys was the beginning of the coil current ramp, which is this section here. The reason I didn't mention it in the last segment is I really couldn't see a real good correlation between when we turn the coil on and either the PIP and SPOUT signal. So if you look at this, I don't have the same kind of cursors that I do. Maybe I do. Let me see. Okay, I do. I have a vertical cursor. We put that one in there. Can you see how the turn on of the coil doesn't really correspond to anything in the yellow trace or the green trace? Can you see that? But the turn off of the coil, which would be this area, remember the blue trace is my coil current ramp. The turn off corresponds with the spout increasing signal. Anyway, that's why I didn't mention it in the last one, is the dwell time. When to turn the coil on, I don't see a clear indication of when they're doing that. More importantly for us that have been involved here is the consistency in the cutouts of the yellow trace, which is my PIP signal. And I will zoom out one level here to show it to you a little bit more. Go 2 levels. Can you see the difference in these patterns, guys? We're looking in here. See how consistent they are? You see the gaps in all of these are the same at the top too? Totally different from what we had. So again, if you don't remember anything else, remember if you have one of these Fords one of these days that has a misfire that you can't get rid of, you've done plugs, you've done wires, maybe you threw a coil at it. Hopefully you didn't throw a computer at it like the first time I did. But if you have one of these, look at your PIP signal, which is the yellow trace, and if you don't see consistency in the PIP signal, which is our crank signal, you have a faulty pickup. Now whether it be the stator that's inside of there, what they call the stator, or whatever fails inside of it, we don't know, don't care for this part. I do care from a theory standpoint, but for what we're doing here, we don't care as far as making the call. Again, the area here that's missing one, is that normal?
Yes.
Yes, that's my number 1 trigger. And everything looks great in this pattern. Let me show them to you separated. This will be the one that you guys that are coming in late on this will be able to really see the difference. All right, see the consistency in the yellow trace? Can you see also the consistency in the blue trace, which is my coil current ramps? This is the new distributor with the timing signals connected, with the spout connected. Okay, I'll show you the old one, PIP and SPOUT old distributor. I believe this is with the spout connected. See the difference. See why this vehicle was misfiring. Even you guys that just came in would be able to tell by looking at the blue trace on why this thing was misfiring. Let me get to a different section where it really emphasizes it. We had a number 2 cylinder that the spark plug kept dropping spark from. We did a visual inspection. When I have this all together, you guys that were doing other projects will enjoy this because you'll be able to see physically, I'm showing the spark is missing from the number 2 spark plug wire coming right out of the cap. And majority of people in the field would put a cap and rotor in it for this problem. Of course, that didn't fix it. It was a coil control issue. It had to do with the faulty pickup signal in the distributor, the yellow trace. Do you see the inconsistencies in the gaps of these? Let me zoom in one level. You'll see it a little bit better. See what I'm talking about would be here. See how thin that is? See how fat those are? You can look at the top part or you can look at the bottom part. But either way, we are lacking consistency in these, right? This is the bad one. Let me show you the good one. One more time. With the spout connected. New distributor with the spout. How's that zoom level pretty good for what we just saw?
Yeah.
See how consistent they are and even? Faulty PIP signal every time. Cool? Question? Go ahead, John.
See the one that's not has the drop in it,
Which one?
right in the center, yellow.
Your question is this one?
Yep.
Yeah, that is
Is that a timing thing?
That is a timing thing. Very good. And there's consistency in that, John. And John wasn't here for our last discussion. You'll actually see that same signal. Here it is right here. And here it is right here. Count them. 1, 2, 3, 4, 5, 6, 7, 8. Back to 1. Not in firing order. I didn't list those in firing order. Just listing there are 8 windows in that Hall effect in the distributor. We fire the coil 8 times per rotation.
Right.
Cool? Faulty pickup. And I told these guys before I made a bad call the first time I saw this, I ended up putting an engine computer in it because the vehicle would run good with a spout connector unplugged. The coil firings are good with a spout connector unplugged. So let's just do a final here on the spouts for you guys that weren't here. Spout unplugged with the bad distributor. Look how consistent the coil firing ramps are. This is the bad distributor with the computer out of influence on the circuit. Look how nice and even the coil firings are. He's been here. What I found out, he's been driving this car this way for 4 years without a spout connector plugged in. They replaced that distributor somewhere in North Carolina, military guy. They replaced that distributor for him down there and left the spout unplugged, and they told him he had a bad engine computer. Brand new out of the box is what happened. Brand new distributor out of the box, faulty pickup. This is not a unusual occurrence on these. I've seen this a handful of times now on these EEC-IV distributor systems. You can still see the sync pattern, right? There's every 8. It's pretty even and consistent. I thought it was kind of interesting here. I don't know if this will tell me anything, but I thought it was interesting that my spout signal is showing those same gaps, but not really the same. Here's your sync signal here and here, but do you see the gap in the spout here and here? Can you see it? It's consistent.
30 degrees off. No.
So yeah, one's influencing the other. What you have, guys, this PIP signal is going in to the PCM, and this spout signal, this is my PIP profile ignition pickup. My spout signal is out from the, well, it's not really a PCM in this year. It was called an ECM. Same thing, engine computer. You remember this discussion? You probably do. Crankshaft position goes to the ICM.
Yeah.
ICM to PCM. Hang on. ICM to PCM. PCM to ICM. ICM to coil. Remember this discussion?
Yeah.
This on a Ford is the PIP signal. This is the spout signal. That's what we're looking at.
Isn't it the fancy one that's like more or less only with like GM Ford that usually do
GM
that?
and Ford. Yeah, GM called this wire was called the reference wire on a GM, and this wire was called the EST wire on a GM.
Okay. So I knew that looked familiar, I just wasn't sure if that was just
Yeah.
Ford and GM.
And as a refresher, guys, if you go to my Section 22 playlist, you'll find this discussion where I'm talking about ignition system designs. I'd suggest going to that playlist and watching it. Section 22.
On your premium channel?
Chapter 22. Yeah, this is on the premium channel already.
Oh.
That'll be the only place you're going to see this.
Wait, where?
Yeah, because this is good stuff.
This is good stuff.
We're
This-
premium channel.
you guys are premium channel worthy. Yes, you are.
We're living.
Wait, hold on. Let's stay focused here for a second. Look at this is the old distributor spout unplugged. See how even and uniform the coil firings are. This is just a mistrigger with a scope. That's nothing there. Don't worry about that. New distributor. I don't know if there'll be a difference. I didn't really look at it yet. New distributor spout unplugged.
Hit the VSM. That's what you were clicking before, right?
Yeah.
Look Looks the same.
Oh, it doesn't look the same.
Oh no, I'm sorry. The green trace doesn't show
It does
the
not look the same.
the green trace.
Yeah, see, here's your number one trigger.
Your spout.
Here's your number one trigger, right? And our firing order for you guys that came in, it was 1-5. Not that it matters here. 1-5-4 2 6 3 7 8 back to 1.
You
Um,
put 7 into the.
What?
You
said
said
them, but
6,
you
3,
put 'em
7,
in
8, and then you wrote 7, 3, 8.
3. Nice. Thank you. 7.
Yeah, you probably got it.
That's 3. That's 7. I do that. I can't tell you how many times I do that, and no one corrects me. And then when I'm editing the video, I'm like, I got to put a note in there, like, yes, I'm a dumbass.
Well,
But
now you don't.
look at the spout signal. Even with the distributor unplugged, it's consistent and even and uniform. So something else that we're looking forward to, all of us, and you guys too that are in here late, pay attention. When I post this video, pay attention to the comments in this one, because I'm hoping to get some forward engineer guys that are like, okay, here's why it's doing that. Here's the internal design. I don't have that answer for you here. All I know is what the fix was. One last thing. We'll end this. You guys can go home. Where's my little dingleberry at?
It's on your butt.
See it? See the little guy right?
Oh.
See the little guy right there? What cylinder is that? Is my point that I wanted you guys to get before we leave.
Didn't you say it was 2?
Yeah, my number one trigger is right here. This is the skinnier PIP signal. So there's your fatter ones. There's your skinny one. This is number 1. And in the firing order, this would be then the number 5. This is the number, was it 4? And then this one's the number 2. And so that's the one. This is the one that's affecting that. Is the number 2 cylinder. It was not a secondary ignition problem. It was not a spark plug problem. It was not a wire problem. This was not a computer problem. This was an input problem. This is the one. This is what I was thinking about whenever, Ben, you told me that his Volkswagen, V6 Volkswagen, was missing spark on 3 cylinders.
Yeah.
And it's a distributor system. This is exactly what I was thinking about, some kind of input problem, which is why I made you guys go in that direction.
Right.
Ford EEC-IV Systems. Welcome to the PIP circuit and SPOUT circuits on Ford EEC-IV. That's Electronic Engine Controls 4. I'll post this up soon. Thanks for helping me out with this, guys. I really appreciate it.